Hi Algebra 2B students, how you doing today? We are working on section 8.4, rational functions. We will be looking at the graphs of those. We will be looking at vertical and horizontal asymptotes and the domain and range. We'll be looking to see how rational functions have been transformed, either moving left, right, up, or down. And we will be looking for holes in a graph, which you've probably not heard of before. So I did make my own notes for this section a few years ago because I just felt the book was lacking a couple things I wanted to cover. I also filled in a ton of these notes for you so that it would cut down on the writing in class and we could do some more work rather than so much writing. So on the front page here, we are going to review past concepts that you will also be using in this section. So let's take a look here. We are going to, by the way, we'll be using the calculator a lot, so be sure to have one ready. So let's take a look. Review of past concepts. Identify the zeros of this graph. The zeros of the graph are where the x is where the graph hits the x-axis. Notice that is where x equals -4 and x equals 6. Here we go. Write equations for the vertical and horizontal lines below. Let's first go with the horizontal line, right? It's flat like the horizon. Notice that this line goes through y equals 2. And so this horizontal line is called y equals 2. The y equals 2 line. We wouldn't just call it 2. It's actually a line. We call it y equals 2. Notice at every point on this horizontal line that even though the x changes, the y is 2. Here is the point 1, 2, 2, 2, 3, 2, 4, 2, and so on. Let's write the equation for this vertical line. This vertical line goes through an x of 5, and so it is called the x equals 5 line, not just 5, x equals 5. Notice at every point on this vertical line that the x is 5, even though the y changes. Let's take a look here. Here's the point 5, 0, 5, -1, 5, -2, 5, -3. Let's go up to C. Oh, we're back to factoring again. Take a look at the numerator here. With the numerator, that is quadratic, meaning we're going to use the x method. We are looking for two numbers that multiply to -6 and add to a -1. That is -3 and 2. There we go. And my a is 1, so when I divide by 1, I don't need to show that. So the numerator is x minus 3, x plus 2. And the denominator, let's take a look. There's two terms. However, it's not the difference of squares because I don't have a difference and nothing is being squared. So I take a look at greatest common factors, and it's a 1, so the denominator stays the same. What is the domain? Those are the x's, and the range of the graph, those are the y's. So an x is in the domain if that x has a y attached to it. Okay, a y is in the range if there is an x attached to that y. If somewhere in the domain there's an x where there's no y, we have to take that x out of the domain. Let's see if that happens as we go left to right. Let's look at the x's. Let's take a look where x is -8, there's a point on the graph. -6, there's a point on the graph. -4, point on the graph. -3, point. -2, point. Let's go to where x is -1, little hard to see. Oh, there's not a point on the graph. So we're going to say x cannot be -1. Okay, let's see. All the other x's, as I go left to right, I see there is a point on the graph, meaning there's a y there. Let's look at the range. Let's go bottom to top, since range is the y's and the y's go vertically. Take a look for each y. Here's where y is -10. There's a point on the graph, meaning there's an x. At -8, there's a point. -6, there's a point. And as I go up, for each y, there is a point on the graph or an x. And so I'm going to say y is all real numbers. So just some ideas from before. Let's take a look at the next page. And this is basics of rational functions. What is a rational function? It has a polynomial in the numerator and the denominator. What is a vertical asymptote? We call that a VA, so we don't have to keep writing it. It's a vertical line that a graph curves towards but does not touch. On the calculator, we can draw a vertical line by using second program. There's a draw above that, so that will help us draw. We're going to choose number 4, which is vertical, and we're going to move our cursor left or right to place or see where there might be a vertical asymptote. What is a horizontal asymptote? We call that an HA. It is a horizontal line that a graph curves towards on the ends of the graph but does not touch. On the calculator, when we're trying to draw a horizontal line ourselves, we'll use second program, but we'll pick number 3 and we'll move up or down to place with the cursor keys to place our horizontal line. When is there a hole in the graph? For a hole in the graph, it's really hard to see right on your graphing screen. It's better to find it in the table because your graphing screen doesn't do such a good job at little specific points. A hole in a graph occurs at an x with no y value, and there is no vertical asymptote there. To find a hole, look on the calculator table from -10, x's from -10 to 10, and look for where there is a y error and say the x where the hole is. Okay, so on E, we're right here. I'm going to put a star here. We're going to graph f of x equals 1 over x. That is the most basic rational function we can have on the right, and we're going to provide the following information. So notice our graph is a basic standard screen on your calculator, -10 to 10 for the x's and the y's. Let's grab that calculator, and on a y equal screen, let's put in 1 divided by x and assume 6. If you take a look here, notice that the graph has a curve in the first and third quadrant, curving upwards towards the y-axis, downwards towards the x-axis, and again here where I'm pointing downward towards the y-axis and upwards towards the x-axis. Let's give that a sketch. I will do that in green. I may run and get a blue pen. There we go. I do not have one with me, and I thought I did. There we go. There is 1 over x in green. And it says provide the following information. We can look on our graph that we drew, or we can look on the screen also. They're asking where the vertical asymptote is. Well, that is the vertical line that a graph curves toward but does not touch. And I see the graph going vertical towards the y-axis from the left and the right here, right? So I'm going to say that my vertical asymptote is the y-axis, right? That is located where x equals 0. Notice the positive x's are to the right, the negative x's are to the left. The y-axis is where x equals 0. The graph is, so I'm going to fill that in on my VA. The graph is curving towards that line but not touching it. Let's look for our HA, horizontal asymptote. That would be where the graph is flattening out towards a horizontal line, which would be y equals something. Notice as you go to the right, the graph is flattening out. It actually looks like a horizontal line itself on the right and on the left. Notice it's flattening out towards the horizontal line that is the x-axis. That is where y equals 0, right? The positive y's are above, the negative y's are below. The x-axis must be the y equals 0 line. There we go. Let's look for holes in the graph. What we said above is we go to the table and we look for where x's are from negative 10 to 10. And we look for an error on the y. Let's go to the table. Let's start where x's are negative 10. There we go. And let's go down to where x is 10 and look for a y that has an error. There we go. Oh, that happens at x equals 0. However, we know that is not a hole. We already wrote that's a vertical asymptote, right? Not just a hole in the graph. So we're not going to include x equals 0. We already put it as a vertical asymptote. Let's go down to x equals 10. There we go. I don't see any more errors. There are no holes. That happens sometimes, actually quite often. Okay, the domain are x's where there are no y's. Well, we already said the domain is the same as the vertical asymptote. We said that the graph is curving towards the x equals 0 line, the y-axis, but not touching it. That means where x equals 0, there's no y. And so we look at our vertical asymptote, notice the x's match, and we say x cannot be 0. For the range, notice it matches the horizontal asymptote here, right? And a range is a y where there is no x, and we said that our graph is curving towards the x-axis, which is the y equals 0 line, and we said it's not touching it. So there must be no there must be no y value there. So the range is y cannot be 0. Notice the domain is easy. It matches the vertical asymptote and later the hole, right? X, x, x. The range matches the horizontal asymptote. Okay, let's go below to, let's graph g of x equals 1 over x minus 3 plus 2. We're going to put this in the graphing calculator clearly, and we're going to provide all the same information we did above, and we're going to now also add zeros, right? That's where the graph hits the x-axis. How do we find zeros of a graph using a calculator? We either look at it, look at the x where the graph is hitting the x-axis, or we do second trace, which is calc. We choose number 2, which is 0. We go left and right with our cursors and then enter. So let's go ahead and put 1 over x minus 3 plus 2 in the calculator. Be a little careful here, right? We're going to use an ND here. Make sure the plus 2 is to the right of the fraction. So here we go. I'm going to use alpha y equals an ND. That's 1 over x minus 3. There we go. And I went to the right, and here's plus 2. Notice our window is still a standard window. Let's do a zoom 6. Okay, let's give this graph a sketch. Going to try to be a little careful here. Let's see, it looks like on the y-axis here that it's going through a y of 2. Just trying to help myself out here. Right, on the x-axis seems to be going through somewhere between 2 and 3. Okay. Here we go. I'm going to give this a graph. There we go. On the upper right here, again, kind of looks like the graph right here is flattening out to y equals 2. And let's see, it's going straight up around x equals 3. Let's see if I can do a good job with that. There we go. Did a nice sketch here. We are going to use the calculator though to be more accurate. Okay, for the VA, we know that's the line x equals where the graph seems to go vertical. Notice that seems to happen here. I think that happens at about x equals 3. How can we find that out? Well, above in number 2, I said how you find a vertical asymptote. Here is your program button. I'm pointing at notice draw above. We're going to do second program, and we're going to pick number 4 vertical because we're trying to draw a vertical line. I'm going to hit enter. I know it looks like the calculator didn't do anything, but as I cursor to the right where the graph is going straight up and down, I can see the vertical line. I'm going to place my vertical line between the 2 curved branches so it's even on both sides, and that does appear to be at x equals 3. So I will put that as my VA. There we go. My HA right here, the graph does seem to be flattening out on the ends. It looks to about y equals 2. Let's find out. Again, we're going to use second program, that's draw, go to number 3. It looks like it hasn't drawn a horizontal line, but I'm going to cursor up to where the graph seems to be flattening out. I'm going to put my horizontal line between the 2 branches and check to see, yep, that seems to be at y equals 2. Again, we're not just going to put 2 for the HA, that's a line, we're going to put y equals 2. Okay, notice on these notes and in your book, the VA and the HA will always be integers, meaning whole numbers, positive or negative. You'll never have decimals or fractions here. Let's see if we find a hole in the graph. That would be going to the table. Let's go from where x is -10, there we go, to 10, and see if there's a y error. That is not a VA. There we go. Oh, there's an error at x equals 3. We already put that as a VA. Let's go down to 10. Again, no holes. Okay, we know that the domain is related to the x's, right? Which is a VA or a hole. My domain then is x cannot be 3. We said there's a vertical asymptote at there. It approaches x equals 3 but doesn't hit it. The range we know are the y's, and we said that our graph is approaching y equals 2 but not hitting it, so the range cannot be 2. Now let's go to the zeros. Does the graph seem to hit the x-axis? It does right here between 2 and 3. Here's how we get a 0 on our calculator. We go to the trace button and we hit second trace. We pick number 2, that's a 0. Notice on the bottom of the calculator, it's asking you, it says left bound. It's asking you to be to the left of the 0. So notice that my cursor is to the left of my 0. So I'm going to let it know I'm there and hit enter. Next, you cursor, it says right bound. You cursor to the right of the 0 until you go past it. Notice I'm down and to the right just a little bit, and I believe I'm to the right of the 0. I'm going to hit enter, let the calculator know that. It wants you to make a guess at the x where the 0 is. You don't need to, just hit enter again. That is 2.5, the calculator is telling you. Excellent. Let's go to the bottom of the paper. Now add the graph of y equals 1 over x in bold from the top graph to this graph. Okay, let's do that, and I'm going to put it on my calculator also. I did it in black here. There we go. I did it in black. Okay, I'm going to put it in my calculator in bold too. Okay, on my y2, I'm going to put 1 divided by x. You could use the alpha y equals to get an ND. I'm going to cursor to the right of the y2 and make it bold. There it is. Let's hit graph. Here's my original graph, and here's 1 over x. And here's what they're asking us. How has the graph 1 over x minus 3 plus 2 been transformed? Okay, let's take a look. Notice that our thin graph of g of x has been moved to the right. How far has it been moved to the right? Take here, we found that this was the x equals 0 line. This was the x equals 3 line it was hitting, so it's been moved to the right 3. So at the bottom of your paper, I'm going to put right 3. Excellent. I also noticed that my graph in bold, that it used to flatten out at x equals, y equals 0, but now that's been moved up. And we found that that horizontal asymptote was at y equals 2, so it's been moved up 2. Just in case you can't see that at the bottom of the paper, I'll just move that up. There we go. Let's finish the back now. Of course, this one's going to have a hole in it because we need to be able to see some holes, right? Okay, here we go. We are going to graph h of x equals x squared minus 4x minus 5 over x plus 1. Let's first factor the expression. Notice the denominator cannot be factored, but the numerator can, using the x method. Two numbers that multiply to negative 5, add to a negative 4, that's a negative 5 and a 1. Notice that my a is 1, and so my factors are x minus 5, x plus 1, divided by x plus 1. Okay, let's get rid of, we know how to answer all these questions into graph. So let's get rid of, let's clear our y equals screen, and let's use alpha y equals an ND to put our function in carefully. X squared minus 4x minus 5. There we go, over x plus 1. And let's do a zoom 6. Zoom 6. Well, that's weird. It looks like a line. Isn't that cool? All right, let's go ahead and graph that. And let's try to graph it a little accurately. Let's see. It seems to be hitting the x-axis at 5. There we go. And it seems to be hitting the y-axis at 1, 2, 3, 4, negative 5. There we go. I'm going to put a line through there. I was expecting 2 branches, but we got a line. Okay, let's take a look. Let's answer the questions. VA, does this graph seem to go straight up and down at any point? No, it does not. And that happens sometimes. We're going to put no. There's no VA. HA, does the graph seem to flatten out towards a horizontal line anywhere, especially on the ends? No, it does not. There's no HA. Zeros, we can see pretty clearly here, or we could go to our table that x equals 5 seems to be a 0. There we go. That's x equals. Let's look for holes in the graph. We know we go to the table. There we go. Let's go to where x equals negative 10 and scroll down to where x equals 10 and find any errors. Let's see. Oh, there's an error at negative 1. There must be a hole in the graph where x equals negative 1 because there was no VA. So we're going to put x equals negative 1. Let's see if we can find any more. Any more errors? No, there are not. Okay, that means where x is a negative 1 on the graph, I'm going to have to make a hole. There we go. The domain, let's take a look. That is where x's do not have any y's. I look at the VA, there weren't any. But look, we said on the table that where x was negative 1, there was no y. So we're going to say x cannot be 1. There we go. The range, well, let's take a look here. We said that where x equals negative 1, that there's a hole there, right? That there's no y there. So notice I have to take that y out. So y cannot be, let's see, let's work that out. Y cannot be, is that a negative 6 right there? I believe so. There we go. right? So at this open hole there, there's no x and there's no y. Okay, there we go. I think we've covered everything. Let's just look to the right. This is information if you were in pre-calc you would use a lot, and I just want to point out some things to you. You can find the VA, the HA, the zeros, the holes, the domain and range by using your calculator. We can also look at the function. A VA occurs at an x value that makes a denominator 0 but does not cancel. Okay, look to the left here at our expression. Notice an x plus 1 cancels out of the numerator and denominator. That's why there was not a VA at a -1. Okay, a hole occurs at an x value that makes the denominator equal 0 but does cancel. Take a look right here. A -1 would make this denominator 0, but it did cancel, and we did find a hole at, oh, look, gotta fix that. There we go, at -1, okay? So looking at the function itself, you can see where VAs are and where holes are. Zeros occur at x's that make the numerator equal to 0 and don't cancel. So take a look here, right, at our function. If you put a 5 into the numerator, 5 minus 5 is 0. Notice that's where we found a 0. What famous song was written about asymptotes? We will do that in class, but just so you know, it's MC Hammer's Can't Touch This. Get it? Because a graph curves towards an asymptote and doesn't touch it. Thanks for hanging out with me today.